And I'm gonna skip a couple of questions because I mean no disrespect, but they're too easy and they don't. I haven't really got the time to go over them. Finding the area and perimeter of a parallelogram is the same as finding it for a square, and the volume of a cuboid the same. If you're not sure how to do it, you can look it up. All right, it's not hard. However, gonna go through the volume of a cylinder. All right, just in case. I'm pretty sure you guys know how to do it, but it couldn't hurt. So I'm just going to try and draw a very rudimentary cylinder. Rightio. This is the part where I find that there's actually one in there already. Like that? Yeah. Okay, so... Okay, let's turn it up like that. So it's like in the project. Alright. Volume of a cylinder. Right. The easiest way to do it is to find the cross-sectional area. If I turn this like this again, imagine this was a Swiss roll or something, or a sausage. Cross-sectional area is if you made a cut, it would be the area of the cross-section of where you cut. So we find that area, which is just the area of a circle, like I covered before, and then you multiply by how many times it goes back, how many units it goes back, so how much space it occupies, basically. So, if we work on the previous example I gave you, if we had a radius of 10, oh, I was hoping I'd remember it. Pi times what? Oh, it's going to, of course, it's going to be 314.16. Yeah. So if you're not sure I'm getting this number from, just watch the previous video. This is assuming the cylinder has a radius of 6. So that's the area on the top. Now let's assume this cylinder has a depth of 16 or something, or a height if you prefer to think of it that way. 16 centimeters. So it means that this area of 314.16 goes down 16 units worth. So what we're actually going to do is do 3.14.16 times 16, which gives us, unfortunately I can't figure that out off my top of my head, 5026.56 centimeters cubed because it's volume. And that's how you do that. Right, so next up we've got the volume of a sphere. Now somebody managed to point out to me in class that the equation for the volume of a sphere is actually it's in your planners. So if you imagine that that's three-dimensional like a sphere, it has a radius that comes out from the centre. So imagine the Earth. It would be like the distance from the centre of the Earth to the surface. That would be the radius of a sphere. Okay, if you imagine you have a radius of 10, kind of cheating now, alright? The formula for the area of a sphere is going to be hard for me to type in here, alright? So bear with me, okay? Did I say area? I meant volume, sorry. Volume is, as a fraction now, 4 over 3 lots of pi times radius cubed. Alright, now might look a bit much at the moment, but let's just start sticking numbers in. Alright, superscript doesn't want to turn off. Lovely. Put in a separate text box. Okay, so volume is 4 over 3 times pi times, I say 10, so that's 10 times 10 times 10, which is 1000. Okay, now let's get our calculator out. So we have 4 over 3 times pi times 1000. 4 over 3 is 1.3 recurring, but I want to get it as accurate as I can, so I'm going to do 4 divided by 3 is 1.3 recurring times pi times 1000. And that's an answer of 4188.79. 4188.79 centimeters cubed, as it's a volume. Okay, so there's your formula for the volume of the sphere. And from then on in, it's simple. You just replace, or the only number you have to replace is the radius, which is, in this example, 10. And that gives you your answer as long as you follow it through and obey the laws of BIDMAS in the, well, oh, you know what I mean when I say that. You do the brackets first, then your indices, and then your multiplying, and then your division. Well, division and multiplication, but what I was actually going to say is, there's one thing I don't like about BIDMAS, and it encourages the idea that you do division before multiplication, when actually they happen at the same time. You see what I mean? Look, if you did 5 times 9 divided by 3, it gives you 15. 5 times 9 divided by 3. But if you did 9 divided by 3 times 5, you still get 15. So division and multiplication actually happen at the same time. And to some extent, it's the same with addition and subtraction. You've just got to be careful with negative signs and think that you're actually adding minus 8. It's a bit weird. But that's the only thing I don't like about BIDMAS. So as long as you do anything in brackets first, then take care of indices, and then do the rest of your multiplying, you'll be alright. Okay?